Okay, so what we are learning is called algebra. Have you ever wondered where the algebra came from?
Sort of, yeah.
Which well, where they came from?
Are you asking me like?
Yeah.
Okay, well, I'm thinking maybe come from like Greek.
No, actually, algebra actually came from Middle East. Is really from Persian mathematicians, which is nowadays Iran. And this is why you see this very interesting there, L. Like remember in the Middle East, the Arabic language, they always have something like that, Al Jazeera or Al Qaeda or things like that. So it has something to do with God, but that's where it comes from. So in terms of math, I really, in a way, I like to describe it as stream. Then, of course, when you have making into rivers, and river can also branch. So it's very hard to just say use a tree analogy. I think a river analogy maybe is a little bit better. So of course, every Asian culture have something called arithmetic, which means it's add, subtract, multiply, and divide, order operation, things like that. But then something happened in Asian Greek. They came with geometry. And that's why you probably think about that as Asian Greek.
Yeah, I think that's what I was thinking about.
Yeah, and Asian Greek with geometry, the tool of geometry actually is very simple. You have, they call something like a straight edge. Straight edge basically allow you to draw a straight line. They have no markers. So geometry has no, in a way, they really cannot measure. We're talking about they call it classic geometry. Classic geometry, they have no way to measure it, but they can draw, they can say one shape is the same as another shape, or one shape is twice of the other shape. They can do that, but they cannot say, okay, it's 10 degree or 15 degree. They have no way of measuring it. So they use straight edge and also use a compass, which allow them to draw a circle. So that's all they have. They can draw a line, they can draw a circle, but with that, they can draw all kinds of geometric shapes. Some are very complicated. So that's kind of come from the Greek. So we had one stream is actually from all the Asian cultures. Then you got from the Greek. And then you also have something come from the Middle East. It's called algebra. And algebra, we use symbols. So that purely just use your pen and a piece of paper. And that's the tool we have. And then this too, when it became a river, we have something called analytic geometry. Analytical geometry. So that's where we see we actually having XY coordinate. Have you learned about XY coordinate?
What?
Have you learned about XY coordinate? No, if not, that's all right. Because we're going to talk about when we actually sometime this school year. And when you have algebra analytical geometry, then you got something called calculus. And that's just on top of that. And of course, once you have that, then they have a lot of branches out that's called higher math. So in high school, at least it's pretty much standard now in many countries. The high school will learn definitely elementary school learn arithmetic, and then in high school we learn algebra, and sometimes middle school can learn that. Then we learn geometry, then we learn analytic geometry, but we don't call that nowadays. We call that pre-algebra, sorry, pre-calculus. And also we have something called pre-algebra. That just help us making the transition from arithmetic to algebra, pre-algebra. And that's what we have when you finish high school. But not everybody will learn calculus. Some of them will, but I think most of them won't. Most of them will stop at finish geometry and algebra. But it's always good. I definitely encourage everyone who is capable to learn calculus. Really, it's amazing branch of mathematics. Really help you to look at things differently, give you a better understanding of the world around you. So now with that, we can go back to our algebra. And when you do arithmetic, that's arithmetic, and then you have algebra. A lot of people have trouble because this too is really like different games. And here we deal with numbers. 2 plus 3 equal to 5, or 7 times 9 equals 63. But in algebra now, we're starting with symbols. We'll say a plus b, or we could have a plus b squared is equal to a squared plus 2ab plus b squared. And we're going to see a lot of formulas once we got algebra. Okay?
Okay.
So the mindset is different. When arithmetic, elementary school, we just do calculations. Everything is, in a way, is concrete, where we see the numbers. Even though number itself is an abstract concept, but we do see numbers. But once we got algebra, we really deal with symbols. And so that's, people got confused. That's why in somewhere in middle school, sometimes the first year high school, you learn something called pre-algebra. It's trying to make the gap between these two. Good?
Okay, so you're not just like jumping head first into algebra.
Right. So it's, in a way, like here, it's kind of like you're playing soccer, and here we're playing football. Now, if we don't tell you this, the rule changed, people will get confused, right?
Yeah.
Because here you use your feet, but once you're here, only one player can use feet. And here you cannot use your hands, but here you do. You just grab the ball and you run. You can tackle each other, but not really in soccer. Soccer, you're not allowed to grab someone. And so without knowing the rule has changed, people easily get confused. And that's why a lot of people have difficulty with algebra, because they never realize that something has changed. So because something had changed, we have to make sure the basic rules were under it. Once we understand basic of the algebra, then things become easier. So what's the rules? The rules, we actually, in algebra, first of all, what kind of numbers we're dealing with. In algebra, we see, well, this is the first number family we'll see. Now, this family is called counting numbers, because that's how we count. We're counting from 1, 2, 3, 4, 5. And then we'll have the next one, we just put 0 to it. and that's called whole numbers. And after that, we'll have integers. We got 0 here, 1, 2, 3, 4. So are you okay with integers?
Yeah.
Okay, very good. That's integers. And then we can throw in the fractions into it. So like this is half, this is 3 and or 5 over 4. So if putting the fractions into it, and this is called the rational number. And then people find something like square root of 2 and pi, those are irrational numbers. So once you have irrational numbers, the rational number plus irrational numbers are called the real numbers. Okay.
Okay.
So in a way, you can look at his thing is that in a number line. At first, you have some markers. But between the markers, between like 0, 1, 1, 2, those are empty space. If we're only dealing with integers, we have a lot of gaps. And then we could throw in fractions, half, a fourth, eighth. It's kind of like a tape. Have you used the tape to measure?
Yeah.
Tape measure, and you see a lot of those fractions there, right?
Mm-hmm.
And but we still have gap between the fractions, like between quarter and half, there's still gap. Between 1/8 and 1/4 still have gap. Well, of course, there is some other fractions in here, let's say between 4 and half. But even you put all the fractions in there, there still have gap. So the way to fill the gap is the irrational numbers. Of course, the simplest one is square root 2, which is 1.1415 and never end, right?
Mm-hmm.
And it's called the irrational number. You got pi. No, sorry, this is actually not square root of 2, 1.4 something. So 3.1415, and that is actually pi. Then you have something called e. And that, good?
Okay.
So with the rational number and irrational number, this whole number line is populated. Everything is full. There's no gap. And that is called real number. Good?
Okay.
Very important. The real number will fill in the whole number line. There is no gap. And that's the things we're working on for algebra. Is the number we're dealing with. So we are playing with numbers. Those are real numbers. And later on, sometime in this course, we're also talking about imaginary numbers. So right now, we just focus on real numbers. So it's numbers. And numbers and operation. Basically talking about addition and multiplication. Good?
Okay.
And then we're also dealing with equations or dealing with inequality, something like that. Good?
Okay.
So that's the things we're working on based on algebra. So because of that, we have the rules. Our basic rules of algebra has to do with the operator. One is addition, one is multiplication. Now, the first rule is A plus B is equal to B plus A. So There are some examples. For example, 2 plus 4 is the same as 4 plus 2, right? Good.
Yep.
So that means when you add something, the order does not matter. Now, this is a different from arithmetic. When we're doing arithmetic, which is elementary school math, there is something very important. It's called order operation, right?
Mhm.
And when you have the same order, then you go from left to right. Good.
Okay.
Now here, we're basically saying that's not true. Well, I mean, you still work from left to right, but you don't have to. Here it says that when you're adding two real numbers, the order does not matter. So A plus B is the same as B plus A. Good?
Okay.
Okay. Now, same thing, you say A times B is the same as B times A. Good?
Yep.
So like 4 times 7 is the same as 7 times 4. Good?
Yeah.
And then we have something called A plus B plus C is the same as B plus C. Good?
Right.
So this is called associative. The first one here is called commutative. Those are the properties when we dealing with addition and multiplication. Now, same thing for multiplication. When you can do A times B times C, or you can always do B times C first. The order does not matter as long as we do add and multiplication. Good.
Okay.
So we have that. Then we all have something very interesting is a number adding a 0 is the same as self. Good.
Yeah.
And also now you can see why we use symbols. If we use symbols, we make them a lot of concise and a lot of clear. A plus B is B plus A. It's very, very clear, right?
Yeah.
And very concise. You cannot make it simpler. Otherwise, we'll say one number adding the sum of two numbers. One number adding another number is the same as that number adding the first number. So the language become kind of convoluted. And that's how when you read the law document is you have that because they don't have symbol to do it. Okay. And so A plus 0 equal to A means a number adding 0 is the self, which means tells us something about number 0. Number 0, very important. And also A times 1 is just A. Okay.
Yeah.
A number times 1 is just self. It does not change the value. That also tells us about the number 1. Number 0 and number 1 are very, very, very special numbers. Okay. Then we have also something like A plus its opposite equal to 0. So like 4 plus negative 4 is 0. And negative 7 plus 7 is 0, right?
Yeah. It makes sense.
Good. Then we have a number times its reciprocal is 1. So for example, 4 times 1/4 is 1, right?
Okay.
Or 2 sevens times 7/2 is 1, right?
Yeah.
So any number times the reciprocal is 1. And this is called inverse property. And this one is called identity. Because when you add 0, does not change the value, or you multiply 1 does not change the value. So to talk about the property of the numbers we're dealing with, we'll also talk about the operations, the addition and multiplication. Okay, then the last one is called distributive property. So A times B, we do A times B, so it's A times B plus A times C. Good?
Okay.
Yep. If you're not clear, we can we'll look more in depth on that. Okay.
Okay.
All we have, if you're on the other side, then we go is A times C plus B times C. Good.
Okay.
So this is called distributive property. Yeah, the reason we do this is because those are the rules, the basic rules. We don't there's not that many to it, but once we understand rule, then we pretty much can do many all kinds of algebraic problems. So that's something we got started with. Okay. Now, something you'll notice, we don't really talk about subtraction or division. And that is also tells us why we have order operations when we're in elementary school is because in elementary school, we also have subtraction. Now, 7 minus 4, which is different from 4 minus 7, right? Good?
Yeah.
7 minus 4 is 3, 4 minus 7 is 3. Of course, they're not equal. So that's why you do from left to right when you're in elementary school. But elementary school, they don't have negative number. Now, when we do algebra, we have negative number. So we know 4 plus negative 4 is the same as negative 4 plus 7, right?
Yeah.
Good? Works,
Yeah.
right? As long as we're doing addition. And also because we have something called negative number. So therefore, the order does not matter. Good?
Yep.
And another thing we can look at is, let's clean up some space, is what about division? Now, 4 divided by 7 definitely is not the same as 7 divided by 4, right?
Yeah.
So this does not work for division. But in algebra, division is simply you multiply the reciprocal of that number. Good?
Yep.
So 4 divided by 7 is same as 4 times 1/7. But now the order does not matter because 1/7 times 4 give us the same thing, right? Good?
Yep.
4 times 1/7 is the same as 1/7 times 4. Make sense?
I think so.
Okay.
Yeah. That would make sense.
Okay. And now we just looking at the last two when we do distributive property. So basically, it's something you see if you have 2 times 3 plus 4. Now we know in the elementary school, we do parentheses order operation, right? So we do 3 plus 7 is 3 plus 4 is 7. So 2 times 7 is 14. But now in algebra, we know we don't have to do this. There's another way of doing it is we can distribute it. We can do, this will be same as 2 times 3, which is 6, then plus 2 times 4, which is 8, and that gives us 14. Good?
Yep.
Same value, right?
Yeah.
So, and that's why because we have different rules are different now. And that's why it's causing confusions for people moving from elementary school to middle school. Because in elementary school, we are told you have to follow the order operation, right?
Yeah.
But the first thing when we get into algebra is we don't follow order operation. We have a different rules now. Good.
Okay.
And but it still work. Okay, just because we are playing a different game. Good.
Yep.
Okay. So that's basically what we have for the first class, is to understand the basic rules. And once we understand basic rule, then we'll be good at doing linear equations.
Okay.
Good?
Yeah.
All right. So I'll see you next week.
Okay. Bye.
Bye.